Hi, in this video, I want to talk about the graphing the two other trigonometric functions, secant and cosecant. In previous video, we talked about how we can graph sine and cosine and tangent and cotangent. Now, to graph a secant and cosecant, we can follow the same strategy as we did for the tangent and cotangent. But since secant and cosecant can be written as a fraction, because secant is 1 over cosine and cosecant is 1 over sine, and we know that in any fraction the denominator cannot be 0, again, like what we had for tangent and cotangent, we will have asymptotes. And how do we find asymptotes? By setting the denominator equal to 0. For secant, if I set the denominator equal to 0, it means any angles that make the cosine 0, that should be an asymptote. And for cosecant, any angle that makes a sine 0, like 0 and pi, are asymptotes for cosecant. So we have two methods for graphing secant and cosecant. First, we can graph them by creating table value, finding the asymptotes, and just plot the key points on the function and find the y values and just graph them. Or we have another method to graph these functions, which is that we graph a sine and cosine, because we know secant and cosecant are the reciprocal of the sine and cosine. So we can graph sine and cosine like what we learned in the previous section, and then graph secant and cosecant based on what we got of graphing the sine and cosine. And I will show you in the next slide the two different ways. If we want to talk about the characteristic of the cosecant function first, so cosecant is 1 over sine. So since the period of the sine function is 2 pi, so the period of the cosecant is also 2 pi. To find the domain, we say the domain is all possible x values, or all possible angles that we can replace in for x, but we know since cosecant is 1 over sine, any angles that make the sine 0 cannot be in the domain. And what angles makes the sine 0 are the multiples of pi, like 0, pi, 2 pi, 3 pi. So these are all the numbers that cannot be in the domain. And since they are not in the domain, they can be asymptotes of the cosecant function. And if we talk about the range, so if you remember, the range of the sine function is all the numbers from -1 to 1. And you can see the sine function in this picture as well. So this red graph, it's a sine function. And when we graph cosecant based on the sine, we can graph the cosecant, which are these blue parts between the two asymptotes, starting from the maximum point, and we can graph a curve going up, or if we have a minimum in the sine function, we can graph a curve which is going down. So these blue graphs, these blue curves are cosecant function. And we know that the range of the sine is from -1 to +1. And it's obvious that the cosecant cannot be in this part of the y-axis. So we can have any values for the range for the y values, except the numbers that are within -1 to 1, because -1 to 1 is the range of the sine. And only and those numbers cannot be in a part of the cosecant. So that's why for writing the range of the cosecant, we say the range can be any number less than -1, that means below this line, or more than 1, which is above this line. And if you want to show it as an interval notation, that's the interval notation for the range. All the numbers from -∞ to -1 and all the numbers from 1 to infinity. These are all the numbers that can be in the range of the cosecant. And we will have the same situation for secant as well, because the domain of cosine is also from -1 to 1. So it means that the range of the range of the cosine is from -1 to 1. So the range of secant can be any number except the numbers between -1 to 1 within that interval. So as you see in this picture, this is one way of graphing the cosecant. We graph the sine, and then based on the point, the maximum and the minimum point that we get for the sine function, we graph curves above or under the sine function for cosecant. And all the x-intercepts of the sine function are the asymptotes for cosecant. But if we want to graph the cosecant without graphing the sine, these are the information that we need. We know that the A is called the stretching factor for this function. The period is 2 pi over b because cosecant is 1 over sine, and the period of the sine is 2 pi over b, so the period of cosecant is also 2 pi over b. To find the domain, we know that any number that makes the denominator makes the sine function 0, it cannot be in the domain, and those are the asymptotes. Any number that cannot be in the domain are the asymptotes. So we can use this formula, or we can just set the denominator equal to 0 and find the points. To find the range, so if you remember in previous slide, I told you that since the range of the sine is from -1 to 1, all the numbers between -1 to 1 cannot be in the range of the cosecant. But this is when we have only the sine function. If we have the sine of bx minus c, or a times sine bx minus c, we have phase shift, we have number for b, we have numbers for a. So we know that the a is the amplitude, and it changes how much we go up and down in the sine function. And d is the vertical shift. That means how much the whole the sine graph will be shifted up or down. So that's why to find the range, instead of saying from -infinity to 1 to -1, we say -infinity to -a plus d, with considering the amplitude and the vertical shift. And instead of 1 to infinity, we say a plus d to infinity. So these are the formulas that if you want to use and then graph the cosecant. But I recommend you always graph the sine, and then based on the graph of sine, graph the cosecant, which makes it much easier. We have the similar actually characteristic for secant function. The period of the secant function is also 2 pi, because the secant is always 1 over cosine, and since the period of the cosine is 2 pi, the period of secant is also 2 pi. To find the domain, we say all the numbers except the numbers that makes the denominator 0. And since secant is 1 over cosine, what number makes cosine 0? So if you look at unit circle, you know that's the cosine axis. So cosine is 0 at this point and this point. So it's 1 pi over 2, and this point is 3 pi over 2. After one rotation, we will have 5 pi over 2. Another half rotation is 7 pi over 2. And these are the numbers that make cosine 0. And if you look at these numbers, it's 1 pi, 3 pi, 5 pi, 7 pi. So that's why we call them all the multiples of pi over 2. Any odd numbers, any odd multiples of pi over 2 make the cosine 0, and they cannot be in the domain, and they are the exact asymptotes of the secant function. The range is similar to the cosecant. So since cosine, the range of cosine is from -1 to 1, and you can see the cosine graph right now, which I'm making it red. So that's a graph of cosine. And you see that all of the y values are from -1 to 1. So that means this part cannot be in the graph of secant. So the range of the secant is all values less than -1 or greater than +1. Again, graphing secant is easier if we graph the cosine function first and then graph the secant based on the maximum and the minimum points that we get for the cosine function. But if we want to graph the secant without graphing the cosine, just using the numbers that we get for A, B, C, D, so you can use this information. The period again is 2 pi over b. The domain means all of the x values except these numbers. And those numbers are exactly asymptotes. To find the range, we say negative, instead of saying -infinity to -1, we say -infinity to -a plus d. Because in this function, we have a and d. We have vertical shift and we have a number that tells us how much we go up and down, and from a plus d to infinity. And we know that the cosine is an even function, which means the cosine of -x is always the same as the cosine of x. And since the cosine is even function, the secant is also an even function. So let's look at an example. It says use the graph of y equals sine of x plus pi over 4, and then based on that, obtain the graph of cosecant of x plus pi over 4. If they ask you to graph this one, I told you one method, or which is also the one of the easiest method, is just graphing the same function with sine, because you already learned how to graph sine function. Just find the amplitude, the period of the function, the phase shift, and then find the 5 key points, and then plot it in the coordinate plane and graph the sine. And after graphing the sine, you can easily, without finding any other point, graph the cosecant. But we know that cosecant has asymptote, and asymptotes are always the x-intercept, where the graph of sine is crossing the x-axis. And you can see the graph of sine in this picture. And the x-intercept and the point that are x-intercepts are the asymptotes, and we can graph asymptotes as well. Now, if I want to graph the cosine function based on these, so just that's the highest point in the sine. So starting this point, we graph a curve and then going up, and make sure that you get close to the asymptotes but not touch or cross it. And we have another minimum point. We graph another upside down U shape without touching the asymptotes. And we can also have part of the graph on this side, but since this is half of the curve, we can just have half as well on top. And that's the graph of cosecant. And you can see in this picture with blue. Next example, we want to graph y equal to secant of 2x. Okay. So I want to use the method of graphing cosine first. So I'm going to graph y equal to cosine, because I know that the cosine is the reciprocal of the secant. I will graph this one, and based on this, I will graph the secant later. And we need to graph it just from -3 pi over 4 to 3 pi over 4. To graph a cosine, we need to know the amplitude, which is 2. Of answers here. We need to know the b, and in this example, the b is 2 as well. And if we have the b, which means that we can find the period of the function. So the period of this function is 2 pi over b, and 2 pi over 2 is pi. And after finding the period, we need to find the 5 key points. To find the 5 key points, we always start from the 0. If there is phase shift, we'll start from the phase shift. Since there is no phase shift here, so we start from 0, and then we need to divide the period of the function by 4, and then start from 0 and keep adding by pi over 4, pi over 4, pi over 4 to get all 5 points. And we get these numbers. Because 0 plus pi over 4 is pi over 4, pi over 4 plus another pi over 4 is pi over 2, pi over 2 plus another pi over 4 is 3 pi over 4, and 3 pi over 4 plus another pi over 4, which is 4 pi over 4 and is pi. After finding the 5 key points, we need to put these points into the function, into the cosine function, and find the y value of each of these points. For example, if I replace the x by 0, I get the 2 cosine of 2, 0. You know that 2 times 0 is 0, and the cosine of 0 is 1, and 2 times 1 is 2. So my first point is 0 and 2. I can replace pi over 4 into the function, so I get 2 times pi over 4. And if I simplify 2 by 4, I get pi over 2. And then what's the cosine of pi over 2 is 0, and 0 times 2 is just 0. So the next point is pi over 4 as a x and 0 as a y. You can replace pi over 2. If you replace pi over 2, 2 and 2 can cancel each other. So we get the cosine of pi. Cosine of pi is -1. -1 times 2 is just -2. And these are all the points that we can get after replacing their key points into the function. By having these 5 points, we can easily graph the cosine. Find the points and then connect to each other. But since we were supposed to graph the function from -3 pi over 4 to 2 pi over 4 to 3 pi over 4, we may need to extend the graph, because this graph is just from 0 to pi. But I need from -3 pi over 4. That means I need to extend it in this direction and stop here at this one. So since this distance is pi over 4, we can go negative pi over 4 into the negative direction, another pi over 4, which is negative pi over 2, another pi over 4, which is -3 pi over 4. And then we can continue. Okay. Now, all the x-intercept are the asymptotes. So 2 of them already graphed. So I can graph the other asymptote as well. You can see the better picture here. And then, if I want to show it by myself, so just looking at the highest and the lowest point on each part of the graph. So we have one minimum here. We can have a curve going down. We can have a curve going up here. And we can have another curve which is going down. And you can see a better picture on this. This method is very easy because we know how to graph the sine and cosine, and then after graphing them, just easily we can graph the secant and cosecant. Next example, we want to graph one period of this function. Okay. I want to graph this one without graphing the cosine this time. So if I don't want to graph the cosine, I need to know what's the period of this function, what's the phase shift, where are the asymptotes. So first of all, we need to know what's A, what's B, and what is C. So the A is 4. The B is pi over 3. C is pi over 2. And D is 1. Okay. Now to find we know that the vertical stretch, or A, is 4. We know that the period is 2 pi over B, which is 2 pi over 3. And if I divide 2 pi by pi over 3 in another form of division, and then keep Philip change, I get 2 pi times 3 over pi. Pi and pi cancel each other, so the period of the function would be 6. That means you want to graph the function starting from the phase shift with the period of 6. What is the phase shift now? Phase shift is C over B. C is pi over 2, divide by B, which is pi over 3. Keep Philip change, so I get 3 over 2, which is 1.5, if you want to just have a bit of understanding where the point is. Now we need to find asymptotes. So I gave you the formula to find asymptotes. So the asymptotes are coming by this formula, C over B plus pi over 2bk, which k is an odd integer. Okay, so remember in this case, the k must be an odd integer because the reciprocal of secant is cosine, and the cosine is 0 in an odd multiples of pi over 2. That's why the k must be be an odd integer. What does it mean? That means you can only replace an odd numbers for k. If you replace, for example, k by 1, if you replace k by 1 and replace the numbers for c and b, so you know that c over b, we have it here. It's 3 over 2. You don't need to replace again. So 3/2 plus pi over 2, the period of the function, which is the b, which is pi over 3, and k is 1. If I simplify this fraction, so I get 3/2 plus, for this one, pi over 2 times pi over 3, you need to divide it in this form. Pi divided by 2 pi over 3. Keep Philip change. Pi and pi cancel each other, and we get 3/2. So and times 1, which is again 3/2. 3/2 plus 3/2 is 6 over 2, which is 3. So that means my first asymptote is x equal 3. Since k can be any odd integer, I'm going to replace another odd number and see what do we get. If I replace k by 3, let's see what do we get. Excuse me. So c over b, which is 3/2 plus pi over 2 times pi over 3, and then this time the k must be 3. And if we simplify this one like what we did in the previous one, so we know that this fraction is again 3/2. And 3/2 times 3 is 6 over 2. So we have 3 over 2 plus 6 over 2, which is 9 over 2. Let me check again. So it's pi divided by 2 pi over 3, which is pi times 3 over 2 pi, which is 3 over 2. And 3 over 2 times 3 is 9 over 2. I'm sorry, that's a mistake. And 3 plus 9 is 12. and 12 over 2, which is 6. So my next asymptote is x equals 6. Now let's replace k by another odd integer like 5, or we can also replace k by -1. Let's see what do we get if k is -1, because -1 is also an odd integer. So we get 3/2 plus, and I know this fraction again is 3/2 times -1. So 3/2 minus 3/2, which is 0. So x equals 0 is also another asymptote. Now let's see what do we get. So we want to graph the function starting from the phase shift, which is 3/2. So let me just graph the asymptotes first. My first asymptote is x equal 0, which is the y-axis. Second asymptote is x equal 3, 1, 2, and 3. That's another asymptote. And next asymptote is x equals 6, 4, 5, and 6. Okay, now we can find the midpoints between the asymptotes. So the midpoint between 0 and 3 is this point, which is exactly your phase shift because it's 1.5. The midpoint between 3 and 6 is 4.5. Now we need to know the y values of these 2 points. What's the y value when x is 1.5? What's the y value when x is 4.5? And this point is 3/2, this point is 9 over 9/2. Fraction is easier for you. So we need to replace this number into the function, into the secant function. Replace it for x and then try to find the y. So I'm going to erase some parts here and then show you how we can find them. Okay, if I replace 3/2 into the function, so we have 4 secant of pi over 3, replace the x by 3/2, minus pi over 2 plus 1. If I want to multiply this one, I can easily cancel 3 by 3, and I get only pi over 2, and minus pi over 2 gives me 0. So I will have 4 secant of 0 plus 1. And what's the secant of 0? Secant is 1 over cosine. What is the 1 over cosine of 0? I know that the cosine of 0 is 1, and 1 over 1 is just 1. So the secant of 0 is also 1. And 4 times 1 is just 4. 4 plus 1 is 5. So if you want to find the y value for 3/2 is positive 5. So 1, 2, 3, 4, 5. So you have these points there. And we need to do the same for 9/2. We need to replace the x by 9 over 2, which is the other midpoint. If you replace the x by 9/2 and then simplify, you get 3 pi over 2 here. And then if you subtract it by another pi over 2, you get 2 pi over 2. And 2 pi over 2 means pi. So I have 4 secant of pi plus 1. Now, what's the secant of pi? The secant of pi means 1 over cosine of pi. And the cosine of pi is -1. So 1 over -1 is just -1. And -1 times 4 is -4. -4 plus 1 is -3. So the other point is 1, 2, 3. It's -3. And these 2 points are the minimum and the maximum point on your graph. Because you know that between the two asymptotes, you must have a U-shaped curve. And one U usually just going up and the other U is going down. And this is how we graph it. Make sure you're not touching the asymptotes. So this is the graph of this function without graphing the cosine. But I believe that if you graph cosine, is much easier than this. So make sure anytime you don't want to graph cosine, you just want to graph the secant, find the period of the function, the phase shift, find the asymptotes by using the formulas. And then when you use the formulas, you need to replace numbers for k. And if the formula said the k must be odd integer, for secant we have odd integers, you just replace odd numbers for k. But if it's cosecant, for cosecant we replace multiples, just all integers, like 1, 2, 3. So you just replace them and find the asymptotes. Let's look at another example. We want to graph one period of this function, but this time I want to graph the sine function first and then graph the cosecant based on the sine function, which I believe is much easier. So if I want to graph the sine function, I need to graph this function, the exact same function with sine. And in this function, I know that the a is 2, b is pi over 2, there is no phase shift, and d is 1. There is one vertical shift. That means the whole function is going 1 up. So the amplitude tells you how much the maximum minimum points going up and down from the center line. B tells you what's the period of the function, and the period of this function is 2 pi over b, which is 2 pi divided by b divided by pi over 2, and that's 2 pi times 2 over pi, and that's 4. If the period of the function is 4 and the phase shift is 0, that means you start from the phase shift, which is your first key point, and then divide the period by 4, and 4 divided by 4 gives you 1, and then 1 is the number that you need to keep adding, and then find all other key points as well. So my 0 plus 1 is 1, that's my second key point. 1 plus 1 is 2, that's my third key point. Plus another 1 gives me 3, and plus another 1 gives me the fifth one. Now I have all 5 key points. But I need to replace them into the function to find the y value as well. 0, 1, 2, 3, and 4. If I replace the 0 into the sine function, I mean this function, if I replace the x by 0, pi over 2 times 0, it's 0. And the sine of 0 is also 0. And 0 plus 1 is just 1. If I replace 1, pi over 2 times 1 is just pi over 2. The sine of pi over 2 is 1. And 1 times 2, 2 plus 1 is 3. And if I replace 2, let me show you. 2 and 2 cancel each other. You will get sine of pi. Sine of pi is 0. 0 times 2 is 0. 0 plus 1 is 1. So we usually have every other point the same. So 1, 1, 1. And 3 is how much we go up for the maximum and minimum point, because we have 2 for amplitude and 1 for vertical shift, and 2 plus 1, that means the whole function is going up by 3 and going down by negative. Oh, never mind. Going up by a plus d, down by negative a plus d. So let's see what's negative a plus d. Negative a means negative 2 plus d, which is 1, and the answer is negative 1. Okay. Because the whole function is going up by 1. So that's why we don't have the same number for the min and max, because we have vertical shift. Now it's time to graph the sine function. Okay, 0, 1, 2, 3, and 4. 0 is going 1, 2, 3, 1, 2, 3. 0 is going up by 1, 1 is going up by 3, 2 is going up by 1, 3 is going down by -1, and 4 is going up by 1. And that's the graph of sine function. After graphing the sine function, we can graph the asymptotes, because we know that these points are the asymptote, because they were supposed to be the x-intercept before having a vertical shift. But now, since we have vertical shift, they are no more at x-intercept. But we can still graph asymptote from these points. And after graphing asymptotes, since I have the highest point here, that means I can have a curve here and a curve here. And that's a graph of cosecant. Okay, let's look at next example. In next example, you have a graph and you want to write an equation for the graph. We have multiples of these questions, especially on the homework. Now the question is how we can find the equation for a graph. When we look at, let's look at the left one, this one. So what type of graph do you see? Since we have an asymptote and we only have one curve from -infinity to +infinity, it reminds me that should be one of the tangent or cotangent function. But if you remember, we said that the tangent is always going up from left to right, but the cotangent is going down from left to right. And this function is going down, which means can be a graph of cotangent. But the question is, okay, I know that's a cotangent, but I don't know what is A, what is B, what is C, or if there is any D, what's D? I believe there is no D because the center between the two asymptotes is touching the x-axis. That means there is no vertical shift. Okay. Now, how we can find A, B, and C? To find the B, we need to find the period of the function. When we look at this function, we know that the distance between the two asymptotes are always a period of the function. And right now you have two asymptotes, this line and this line. And the distance between the two asymptotes here is 2 pi over 3. So that means the period of this function is 2 pi over 3. And you know that the period of the cotangent function can always be found by this formula, pi over b, which means the 2 pi over 3, which is one period of the function, must be equal to pi over b. And that helps me to find the b. I can solve this one to find the b. How we can solve this one? Let's do the cross multiplying first. If I do the cross multiplying, I will have 2 pi times b, which is equal to 3 pi. Now to find the b, I need to divide both sides by 2 pi. And the b must be equal to 3/2. Okay, I have the b as well. Now we want to find A or C. C is the phase shift. phase shift means how much the whole graph is going to the right and to the left. And we know that always the midpoint between the two asymptotes touch the x-axis, which is our x-intercept. And right now, between the 0 and 2 pi over 3, the halfway is exactly pi over 3. And you see that the graph is touching the x-axis at exactly pi over 3, which means there is no phase shift. So C is also 0. So the only thing that's left is finding the A. So far my equation is like that. A cotangent of 3/2 of x. Now how we can find A? A is a vertical stretch. And this vertical stretch is usually based on how steep is the graph. You know, from the midpoint, how steep is going up or down. That tells me that what's the vertical stretch. And based on what we learned to graph the tangent and cotangent, we know that if the midpoint is here, we have another midpoint between this asymptote and the and this midpoint, and that is going up by a value. And if you look at this point, and you see that's exactly on 1, because we know that the 1/4 and 3/4 point are going up and down by a and negative a, going up by a, going down by negative a. And as you see, this point is going up by 1, and this point is also going down by -1, which I believe the a must be 1. So if a is equal to 1, so the final equation is cotangent of 3/2 of x. That's it. That's the equation of this graph. Now to find the equation of the right one. Equation of the right one, when you look at this graph, you will see that it should be one of the secant or cosecant graph. Okay. We need to know what is this function actually. If this is a sine function or cosine function. If we can find this one, we can easily find the graph of secant or cosecant. As we see in this graph, one period of this function is 8 pi over 3, because we have the graph from 0 to 8 pi over 3. And if period of the function is 8 pi over 3, since the period of the secant and cosecant or sine or cosine, whatever, is 2 pi over b, you can easily, using this equation, find the b. And if you do the cross multiplying, you can see that the b must be equal to 6 over 8, which is 3 over 4. Okay, I have the equation of b. If you look at this, it looks like the graph of a cosine, because the graph of cosine always starts from the half of the semicircle. And how much up and down the curve is going, it tells you the amplitude. And the amplitude of this cosine function is 1. So a must be equal to 1. And since it started from 0, that means there is no phase shift. The c must be equal to 0 as well, because the graph of cosine, which I made it red, starts from 0. Is there any vertical shift? No, because our x-intercept are exactly on the midpoints, because half of the 8 pi over 3 is 1 period, the half of that is 4 pi over 3, half of the 4 pi over 3 is 2 pi over 3, and half of the the midpoint between 4 pi over 3 and 8 pi over 3 is 6 pi over 3, which is 2 pi. So we have all the points on the x-axis, so that means there is no vertical shift. And now we are ready to write the equation. Since this red graph is the cosine, so the reciprocal of the cosine is secant. So this blue graph can be equation of the secant. A is 1, B is 34, there is no C and there is no D. And that's the equation. And the last question of this section, it's using trigonometric function to solve real world scenarios. For example, it says suppose the function y equal 5 tangent of pi over 4t marks the distance in the movement of a light beam from the top of a police car across a wall where t is the time in seconds and y is the distance in feet from a point on the wall directly across from the police car. Find and interpret the stretching factor and the period of this function. If you look at the equation of this graph, what's the stretching factor, or A? The stretching factor is 5, and the period of the function is, since it's a tangent, period is pi over b, which is pi over 4, and if you do the cumulative change, you get 4. So what does it mean now? What does it mean that the stretching factor is 5 and the period is 4? The stretching factor is 5 means that the beam of light will have moved 5 feet after a quarter of period. Why do we say a quarter of period? So we said that the period of this function is 4. And if you want to graph this function, your graph must be from 0 to 4. And the midpoint is 2, and the midpoint of this distance is 1 and 3. So if you replace the t by 1 into this equation, you will get 5 times tangent of pi over 4 times 1, which is pi over 4. The tangent of pi over 4 is 1, and 5 times 1 is 5. When we say the stretching factor is 5, and 5 is when the t is equal to 1. That's why we say that the beam of light moved 5 feet, because y is the distance based on feet. So we say A is 5 feet after a quarter of a period, which is this point. And when the period of this function is 4, means every 4 seconds, the beam of light sweeps the wall. Because the period is tells you that how the graph is repeating. When you have the period of 4, so you have a function from 0 to 4, you have another same function from 4 to 8, 8 to 12, so which means that every 4 seconds, the beam of light sweeps the wall. And the distance from the spot across from the police car grows larger as the police car approaches. Now, part B says graph this function on the interval of 0 to 5. So that's a tangent function, and we can graph it like this from 0 to 5. You can just plot in point and find an answer, because we have phase shift. Sorry, we said the period is 4, but this wants to graph it over the interval of 0 to 5. And then the next part is asking you to evaluate f of 1. F of 1 means replace the t by 1, and if you replace the t by 1, we get 5, and which means that since the t is time, it means that after 1 second, the beam has moved 5 feet from the spot across from the police car.